you can actually, see the terminal. Sometimes, though, it is somewhat difficult to see the actual screen, but we'll get to that kind of in a moment. Are you ready?
Yeah, we're ready.
Okay. So anyway, I wanted to kind of, basically kind of give you guys an overview of what we've done with the terminal. Now, we've upgraded the entire terminal. First of all, instead of using the internal NAND flash memory, which is limited to 64 megabytes, we are now using and running everything off of the micro SD card here in the back. This is a 4 gigabyte micro SD card that currently runs basically runs the entire system. The only thing that the NAND partition inside the clock is used for anymore is the bootloader. Hey, Raul, do I need to talk slow so you can translate, or does everyone understand English?
Yeah, it's okay.
It's okay. We'll stop you
Okay.
if we need.
Okay. So currently, the SD card has two partitions. One, which is where the kernel is stored, and another one, which is where the root file system or the applications are stored. Currently, the terminal ships with a 4 gigabyte card. However, we can support up to 32 gigabytes of data on the back. So everything is running off of the back card here, and this is where the Java runtime and the new kernel are loaded. We're running, I know that right now, the current kernel version that we're running on the Synergy platform that you guys currently have is version 2.4.17. We have now upgraded the kernel to a recent supported kernel. It's version 3.2.4. So the kernel has been migrated up as well, and supports things. We also have some support for wireless or 802.11n with WPA2 enterprise cards as well. We actually have a Wi-Fi module we can install inside the terminal, so we can now support Wi-Fi internally in the terminal. So we've done a lot of upgrades with that. This is not just a adding Java to the clock. This is actually an entire rewrite of the entire system. So we've added that. We support Java. That's basically the primary. We've designed a graphical framework around SWT. SWT is a Java library that allows you to basically draw images and things on the screen. It also has native calls, so there's some native libraries on there that basically help with the overhead. We do support a little bit of the Swing UI, which is the common Java UI, but it's kind of slow on this terminal. So we've opted for a standard SWT, which is from IBM, which runs Eclipse. So we use the SWT graphics package to basically run the graphics for the Java applications that we have. Currently, the Java application supports fingerprint, and it also supports HID. I'm still working on drivers for barcode and magstripe currently, but Java does support that. It's a full Java 1.6 implementation. Java 1.6 is currently supported by Sun Microsystems, so we have a full working version. There's no, it's not a micro edition. It's the full standard implementation of Java 1.6 on there. We've obviously added a lot of features too. I'm not sure if this is something that you guys would be interested in. We can do full streaming video as well as full video playback. So we're going to load a video here and it's going to play a video. So I don't know if you can see that or not, but it's actually full frame video on the terminal as well. You can go ahead and I'll show you a little bit there. I don't know if you guys can see it or not. Can you guys see it okay?
Yeah.
Yeah.
It's a little bit small, but
okay.
We can see it.
Yeah, that's better.
So yeah, we can do full frame video on the terminal. We can also stream video directly from the camera as well. So if you wanted to, say, see people walk up to the terminal, if you wanted to record videos of them as they're making their punch, or if you wanted to just access the frame buffer of the video, we can now do full frame video on the terminal from the camera as well. So there's a lot of kind of like bells and whistles stuff there. All the same stuff. There's still relays. There's still lights and toggles. That's all still in there as well. We also added a feature, and I'm going to go over to the computer here in a minute on the big screen, but we can actually control the actual interface of the terminal via VNC. I'm not sure if you guys are familiar with VNC right now. You can see on my GoToMeeting session, I have a VNC viewer. This is my Windows desktop because GoToMeeting doesn't support Linux, so I have VNC over here, basically allowing me to show you my Linux desktop so I can show you some of the coding stuff that we're doing. But the same thing can also be available on here. We just toggle VNC on, and let's see here.
Para poder estar viendo otras máquinas.
All right, so if I go over to the computer now, and let me see what my IP is real quick. So if I go over to my computer, my VNC session, I can control the desktop of the clock remotely. So I'm just going to type in the IP address. The IP address is right up here. I'm just going to enter that in as my server on my desktop computer. And I'm actually viewing the clock. So this is the actual clock screen that you're seeing over here, now being displayed over here. And and because I basically standardized everything, the keyboard driver that is using the Fusion on the terminal, see these F keys up here, F1, F2, F3, F4, and this is F5, in is F5, and out is F6, and menu is F7. So basically, if you use those keys on your keyboard, your actual physical keyboard on your desktop, you can actually interact with the application. And as you can see, I pushed F7 on my keyboard, and now the menu is there, and I can actually scroll using my arrow keys up and down on the device. So I'm actually interacting directly with the application, basically going up and down and doing whatever I need to do. So yeah, I basically have full VNC control. I can basically if I wanted to view a schedule here, I push F1. F1 is mapped to this key. It's asking for my finger on the terminal. So I just place my finger on the terminal, and now it's showing me location. So I can basically that as well.
Your screensaver came on.
Yeah,
Hello?
Your screensaver is it's on your computer right now. We can't see anything right now.
You can't see my computer?
Your screensaver was on.
Oh, sorry. Oops. So yeah, there we go. I just put it back on. You can see it now, can you?
Yeah.
Okay. So yeah, basically I'm interacting with the terminal directly as if I were in front of it. Even though I'm remotely, I could be 100 miles away, and it would still allow me to interact. So I can select items. I can register a punch if I want to. I can do anything that I need to do on the terminal. So this is just a menu of selecting a different job description if I needed to do that, and it will allow me to make a punch. So we have that element of it. We support full SSL in the Java 1.6 stack. So if you have SSL customers, as if I know that you guys do because I'm currently working on trying to fix your old code with the SSL issues that it has. But this is a full Java implementation with SSL support, so all of that is supported. I'm going to kind of go over now to the computer side of it and kind of show you some neat stuff over here. So one of the things that's kind of difficult to do with any embedded system is debugging. And because we're using Java 1.6, which is a currently supported Java implementation, we can run our actual clock applications that we're currently running on the clock right on our desktop without ever actually having to interface with the terminal. So in order to do that, all I have to do is go over to my IDE. This is Eclipse. This is a popular IDE that many people use, and I can just simply pick my project, which is this is the exact same code. All I have to do is export a jar file into the clock, and this exact code that's running on this desktop will run on the clock. So this is a keypad module. I don't have the enrollment device hooked up, but I could have that hooked up if I needed to, and I can enter in a user ID, and a punch will be registered and it will save, and pretty much everything that I wanted to have before in terms of debugging is currently available on the thing. So this is the actual working, application on the desktop that's running on the clock. It's exactly the same thing. So they're basically running the exact same code. I can do all my debugging and everything else that I need to do. Now, another thing that's really interesting too is that everything, all localization and every single text field that's on this clock, whether it be a menu item or it be a picture or any kind of text that we're displaying, all of it is configurable in a text file. So the date, for instance, if I wanted to change how the date was represented on the screen, and let's say I have I think I have it as day, month, year. So if I wanted to change that to something else, if I wanted to have 2 digits for the month, and I wanted to put the year first, all I have to do is rearrange how I want it to look. I save the file, I come over here, I run the same application again, and now you'll see that my year and my month, or my year, my day, and my month are all in that order. All I did was change, the order in which I wanted to have it formatted. I can export this exact jar file to the clock, and it will be changed. There's no coding that needs to be done. There's no recompiling of the code that needs to be done. Everything is configurable through this text file interface that we have. So I can change the function keys if I want them to display a different function name. So I want to say Grupo Trace on the function key on the main menu. I can do that. So I go over here, I hit that, and now I have Grupo Trace listed as the function key that's going to be listed on there. I can now all I have to do is I want to go over to the clock. I do export runnable jar file, and I'm going to export the file out, and come back over here. Kill the Java application on the terminal. Okay, so I've killed the Java application. I'm going to restart. I'm going to reboot the clock just so we can keep going on and keep going. So I'm going to reboot the clock, and so we'll get back to that in a minute while it does its thing and reboot. But everything, again, like I said, everything is controllable through a text file. There's 2 different text files. This is an internal text file that's part of the jar file. That way it can be edited easily by customers or what have you. You guys have control over that. This is actually a resource file that lives inside the jar file. And I really need everything. Everything from the text that displays on message dialog boxes about placing your finger. If you wanted to basically code this in Spanish and have it say, what you needed to have say in Spanish, you don't need to go back and recompile the code. You go into the text file, you put all the Spanish, localization that you need in here, and when you hit enter, it will, or when you run the application again, all those changes will be updated. The pictures that are displayed on the front, we have a Time America logo. This is the logo that's displayed. I can change this logo field, and a new logo, as long as it's in the, inside the jar file, will basically be put on the screen. So all of the configuration for logos and everything else is all in one convenient place. It's not scattered throughout the code. It's in one place. The images for enrollment and internet settings, all of this is here. The TZ folder location, everything is configurable through both this file and then there's one other file. This is a file that lives outside the jar file. So this basically is what tells the, it lives on the file system and can be edited. A lot of, time-intensive software that we interface with, they have, keys, software keys that have to be used. I know that you guys currently are using MAC addresses to basically validate your, your terminals against your software. Well, if you guys wanted to move to a different system or if you guys wanted to change things, you can put a web service key in here, and this is the web service endpoint that it points to. And basically, this is what we'll take the clock to. So there's a lot of different things that are that are going on here. We have different identity device modules. I don't know, how familiar are you guys with Java?
Yes, we we are familiar with Java.
Okay. So, go ahead. I'm sorry.
No, it's okay.
Okay. So if you guys are familiar with Java, you guys understand the idea of interfaces. And basically what we've done is we've made everything modular. This entire code base was written by me here in America. There's no, nothing came from Israel. It's all done. I've written everything from the kernel sound driver, and modified the bootloader all the way up to getting Java 1.6 to run on this thing. Every bit of this project is mine, and I'm actually quite pleased to be able to present it to you guys. But everything is done in a modular fashion. So the idea too was also to not only provide an application to you, but to provide basically almost a graphical user library that integrated some of the devices. So we want to be able to have this code be supported across multiple customers, you guys included. And in order to be able to do that effectively without having too much code getting too diverse and too spread out, we made everything modular and everything conform to interfaces. So if this is one of the first interfaces that we have, this is the identity device interface that incorporates the fingerprint or biometric reader that is on the clock. And so here is the actual Java file that conforms into the interface and basically implements those methods. So we can open and close the device, and there's a library on the clock that basically talks to the Java runtime that basically handles opening and closing the device and doing all the identification that needs to be done on the device. So because this is done... Yes.
Will this software run on the current hardware that we're actually distributing right now?
Yes, this is a Synergy clock right here in my hand. This is the same hardware that you guys currently have. It runs perfectly fine. There's an update procedure where you can execute a repair file. I have let me see if I can show you the repair file. You guys will actually understand it.
And when you said at the beginning that now it runs on the SD memory card, that means does the current terminals have that SD card, or we have to upgrade it with that?
We would have to put the SD cards on your current terminals. And the SD card, we're shipping them free of charge, basically to our customers so that they can put them on there. I mean, it's a very simple upgrade. You take the terminal off the wall, you pop it in, and you're good to go. The actual process of updating the terminal is very simplistic. You guys are familiar with the repair files, the way that we do them now, where you basically run a repair. This is a very similar thing. We have a repair. This is called the repair.java that you would, you'd rename to repair. You'd put it on the old terminal. You would run this repair file, and what it's doing is it's basically copying the bootloader, which is this uboot.bin, onto the clock, and then basically it's writing the bootloader to position 0 of the NAND flash memory. So the bootloader is transferred onto the clock that you currently have, is then copied to the clock, and then when the clock reboots and the SD card is in place, the new platform will be available. Basically, you'll have the SD card already in place. The clock will reboot, and it will go from there. So you can actually even run this script to update your clock. If you sent your, let's say for instance you sent your customers basically SD cards. You say, hey, just put these SD cards in the back of the clock. They go, they put them in the back of the clock. You guys, Telnet or SSH into the clock. You run this exact script, and the clock will then have the new platform put on it with this new code. So let me go back over to here real quick. I rebooted your application, and I just wanted to show you guys. I don't know if you guys can see it or not, but the Grupo trace is now listed down below here, and the date format is basically the date format we discussed earlier. So this is, again, the exact same code. I did this right here as I was talking to you. So, again, everything is configurable through files, and every terminal that you guys currently have can be updated to this. A lot of the issues that you guys had with reboots and segmentation faults and trying to figure out, your code, why it wasn't working the way it was supposed to, and et cetera. Having this full debugger, basically, this Eclipse environment, which I'm not sure, what you guys use for your Java purposes, but I use Eclipse. Has a full integrated debugger. We can step through the code line by line and figure out exactly what's going on. And ideally, you could run the entire application from here without ever having to interface with the terminal, and then put it on your terminal, and you'd be good to go. So, like I said, everything too is modular. So when you guys make your module, if you will, the Grupo Trace module, right now I have one for a company that we're working with. This is their module name. So I basically just tell the software, go pick up this module, and this is the class we're using reflection in Java. This is the class we're going to use to basically interface with, with the application. So if I go over here first to the excuse me, to the main method, you'll see here where we're doing some reflection stuff. So we're instantiating the web service class, and we're going to the web service package. So this web service package was for a company that we were working with, and their web service package is right here. And as long as they conform to the interface, which is defined in the web service .java, as long as they conform to this interface, which is some pretty standard stuff. We can get the time, we can send the fingerprints, we can get fingerprints, we can, get server data, we can send punches, we can send multiple punches, etc. As long as we can conform to this interface, we can do anything we want to do, and everything is abstract in a way. So basically, you wouldn't really interact very much with the base classes. You would basically just be implementing the interfaces and running on top of that, and basically attaching your jar file on top of it, and it would basically handle all of your connections and all of your processes that you want to have done. So, again, a very modular interface so that we can kind of keep the code base for each customer that we have very same. We can change interfaces, we can modify. I had a customer that he was using alphanumeric badges as opposed to or alphanumeric barcodes as opposed to digit barcodes. And so I already had to change this interface where we send the punch to include a string instead of a user ID. And we can definitely do subtle changes like that to help modify the code to where you need it. But a lot of the work in terms of displaying things and everything else is done. Most of the work basically has to happen with your actual implementation. Now, do you guys use WSDL? Raul?
So we use what?
WSDL.
Whistle?
Yep.
No, we're not familiar with it.
No.
Okay, so WSDL basically is Web Service Description Language. So I know that you guys are using web services.
See?
We don't understand, but it's the description for a web service.
The description of a web service you were talking about?
Yes.
Okay, we didn't hear right.
I understand it. So there's
Yeah.
Okay.
So you guys do have a descriptions for your web services available, right?
Right.
Okay. So in order to basically speed up implementation of your development, we can actually access your WSDL, and basically there's a process called WSDL, or description, or basically turning the descriptors into actual Java code. So we can go to this is what our WSDL, if you will. Let's see if it's even up. Basically, we have our own WSDL, and for our own time and attendance solution. And all we do in order to basically incorporate that new WSDL is we access it and we point our Java runtime to it, and it will actually auto-generate code for us. So let me show you here. So this exact time package that we have over here, this is all this employee.java. Everything here except for this last code, this last file, was generated automatically from my WSDL, my descriptor. So I point my browser to, I'm going to show you over here. So you've probably seen stuff like this before. I mean, this is nothing new to anybody who's done a lot of Java, but let me grab it over here. So this is basically our descriptor, our service description. So I can do WSDL on the end, and here's my descriptor. So I can point, take this URL, come back to my Java area. Oops. Ah.
Will, can you hold for a minute?
Yep.
Thank you. Okay, we're back. Well, I just want to make sure we were on the same page and we were following what you were saying.
Okay. Okay, so again, we can auto-generate our web service client. I showed you earlier the WSDL. This is our WSDL for our time and attendance thing. You guys probably have something very similar on your, WSDL comes from up here, Web Service Description Language. People call it WSDL. So right here. Anyway, so we can go back over here to our web service client, and we can say where our service definition is. Let's see here. Here we go. Yeah. Okay. And let's see here. Hold on.
Fine type? No.
Sí, que es donde está el web service.
Come on. There we go. Okay. So now I picked up my WSDL. I had to type in the I guess lowercase, it was case sensitive or something, I don't know. But yeah, there's a descriptor, and then I can actually tell it to assemble my client for me, and it will put the client in that folder. And again, all I did, I've already generated this WSDL before. So basically, this code right here is all generated from from there, and it was generated basically this is all auto-generated code that basically came from my WSDL. You know what I'll do too? I'll delete this so we can kind of delete. I go back over here. And there we go. There's the auto-generated code again. So there is basically all the stuff I need to have, and good to go. You there?
Yeah, we can do it. You can see it.
So yeah, this code right here is the handler. So basically, it interacts with these Java objects that we've created up here, and basically tells them what to do. So most of the code that would be what you guys would be writing is it's receiving input from threads that are in here. So this is one of the main threads, and in here this is the one that basically gets from the identity device, so that be HID or fingerprint device or whatever. It gets the ID from the ID device, that we've selected, whether it be fingerprint or keypad or HID, and then it sends it to the web service. The web service send punch. If I have this one specified in my reflection, which is, whether it be this, if it's exact time, I would change this to exact time web service, and I would change this to, actually, let's see, exact time web service, and this would be, it's exact, not exact time, so hold on a sec, the exact time, and this would be exact time web service. When you run it, it should pick up that. These are the properties, exact time, and so it's going to go get and establish a connection to the exact time service. It generates the labor levels, and we're basically now talking to our exact time web service. So enter punch, and I think there's actually an error because I regenerated the WSDL. Must have been an update to it, but I have to resolve this. This is where it's basically running into it. But it basically sends the information to this method, and it basically performs the dialogues. It plays the sounds. It opens the relays if it needs to open them. I mean, we have all the helper classes here that you need to be able to do stuff for opening and closing relays, or turning lights on and off, and everything is controlled inside these methods, and you can do anything that you need to do. So it's a very, very powerful, very robust, allows for easy debugging. Kind of a step up from where we were at. Do you guys have any questions?
We have to, not really, we have to dig in the code
To get more information and maybe get back with you, because it's a lot of information. Maybe after we review the code or
Okay.
in this one on a terminal here, we can have more questions and stuff.
Okay.
Looks powerful. It looks that we are going to debug easily, or
Yeah.
we can find our errors or defects that we already had. No, but it's kind of powerful right now to see all those kind of stuff that you are doing.
Yeah. So again, everything written by me here. I don't have to go back to Israel for everything. Everything is also done the right way. There were a lot of quirks about the system, about how it stored information, and there was read-only partitions here, and we were really kind of limited, and we really eliminated all of that. And if the terminal should ever go down or whatever, and you want to have all the information, maybe you have a certain customer that has a specific application, the SD card, all you have to do is pull the SD card. Everything lives on this SD card in the back. So if you take this SD card out and put it into another terminal, it will be as if you moved the entire terminal. It'll have the same web service keys. It will have the same application. You don't have to do anything. All you have to do is pull that SD card in, put the new one in, and you're good to go. If the SD card fails, just swap it out.
Well, what about if we have offline punches? Will they move with the
Yeah.
SD card?
Yeah, they will move with the SD card. So, for instance, would be, okay, I have a module here that's called a log-to-file module. So this is the default module that's currently built into the system. You don't have to use it, but basically what happens is if for some reason your module fails, so a lot of the modules that I deal with are based off of web services. Well, sometimes the clock is down. So basically, if the module throws an exception and is unable to perform its task, it will basically launch this log-to-file module by default. And this log-to-file module will basically save punches to a file that's on the system. It's basically an object-oriented database that's on the system. And the punches will move, the offline punches will move if you take the SD card out from one place to another because the database lives on the SD card.
Okay. Well,
And, yeah.
just looking at a higher level, we want to move forward just replicating what we currently have. Meaning we want to have the same functionality that we have right now with the new code, but with the new code. So being able to enroll, punch in, work offline, be able to work with the relay.
Yep.
Update property. And I'm not sure how much we need to change on the server side or on the web service side.
What I would really like to get from you, in all honesty, and maybe, like I said, maybe I can talk to my team here. Maybe I can make a visit out to you guys. I don't know, something like that. But I really feel as though if I had your web service descriptor, we could basically implement a lot of this stuff out of the box. I mean, it's going to generate much of the classes that we need. So if you're passing a properties file, or if you're passing whatever, that can all be handled by this. There's no doubt in my mind that we could basically do everything that we're currently doing on the old code, but more efficiently with better stability on this platform. So
sounds good. I mean, yeah, we're all for that. I mean, we really want to move forward in a very quick way, but in a safe way.
Yep.
And make sure we can test it thoroughly, so we start eliminating all the problems that we're currently having.
Yep.
If it's a software problem.
Yeah. I understand that we've had challenges with hardware and going back and forth with that, etc. I do feel as though this system, to a better degree, is a lot more stable. I will tell you too a little bit that the boot time on the system is a little bit slower. We're averaging on the boot about 2 minutes, but once the application is up and running, it's just as responsive as the application that you currently have. So we're not seeing any lag or difference or anything like that, but it does take about 2 minutes for it to get up and going. And another thing, too, is that a lot of the issues with the segmentation faults where you guys would have reboots or things just not working properly because you can't make them work properly because the system has this read-only partition or whatever, all of those issues are pretty much eliminated. And the ability to debug the application on your system and see what's happening, and the fact that Java has a very safe mechanism of exceptions and exception handling, where you can do things where, I mean, it's very difficult, in my experience, very difficult to crash the Java runtime environment. So you will, you can, if there's an error in your code and something's not performing or there's an exception, you're going to know exactly what line of the code failed to execute. and that's just inherent within Java. So I think that will provide you guys also a quicker turnaround. I know you guys have been working for over a year on your current application, and sometimes we'll have problems that can't be diagnosed because we have to go hunting line through line to see, what memory was, triggered wrong or accessed invalid or wasn't freed properly or et cetera. All of that stuff is basically eliminated, and more of the, getting the application to run is more the priority of the Java platform.
Okay. I'm really not worried about the boot time because hopefully with this application it will not reboot.
Yep.
We tell us to reboot.
Yep.
So reboot should be only when we tell it to reboot, and it shouldn't be happening randomly.
Correct.
Okay.
All right.
How do we, what's the next step?
Well, I would like to talk with my team here after we have this meeting and figure out what we need to do going forward. A couple of things I could basically ask of you, or I could get you to. Number one, I want to send you maybe 5 SD cards that have the current platform on it, as well as the repair file to upgrade the terminals to the current platform, so that you guys can take some of your platforms or some of your terminals that you have there or whatever, and just get a feel for it. I'll send you 5. You don't have to run 5 at one time. You can just run 1 or whatever, just so you can get a feel for it. I then want to forward you guys the Bitbucket. Everything's hosted through Git on Bitbucket, the Bitbucket repository link, so your team can go in there and kind of feel out the code. But I think, too, depending on how eager you guys are to get up and running, maybe, like I said, maybe a visit out there or something like that might be beneficial to kind of like get the ball rolling. Like I said, I did write this stuff, so I'm very familiar with how it all works, and I'm very quick at getting things, up and running and getting off to a good starting point, and then kind of leaving you once you guys understand, what you guys need to do, leading you from there.